In this video, we are going to do revision exercise 12.2. I first skipped one because the statistics was very basic, and I don't think that you struggle with basic statistics, but you can go in the textbook through basic statistics. So I decided 12.2, and this is going to be probability and statistics, and you will find it on page 701 in the Namibian Ordinary Level Mathematics textbook, y equals mx plus c to success. Now, before I start, because this is actually difficult chapters, but I don't think it's really that difficult. Okay, so I just must run very quickly through the basics, and then I can do the examples. Okay, let's just make it a bit bigger. And as I said, very, very briefly. Now, let me first explain to you what is probability. Probability is your chances of getting success. So I always like to use this example. There's 200 tickets. And you go and you buy none of that tickets. Your chances of winning is 0. It's impossible. So if you buy one ticket, your chances of winning is at least 1 out of 200. And if you buy 10, 10 out of 200. And if you really decide you want to win, okay, let's just make it nice, you buy 200 tickets. What is your chances of winning? It's 200 out of 200, and that will be 1. You are definitely going to win. It's a certainty. So probability is always a fraction. You can actually say between 0 and 1, or from 0, but then I don't want to use the fraction, a number from 0 to 1, anything in between. Okay, and that is what probability is. Impossible, certain, and anything in between. Now, probability of single events, I personally don't think you will struggle with that. It's just if you throw a dice, what is the total? There can be a 1, 2, 3, a 4, a 5, and a 6. So the probability of a 2 will just be 1 out of 6. Okay, I'm just going to go on. The single events is not so difficult. Just want to get that line away. Okay, so using probability to find an expected number. So now they will give you the probability, and they will say a fair dice is rolled 300 times. How many times would you expect to roll an even number? So you must first see what is the probability of even numbers. It will be 2, 4, and 6. So it's 3 out of 6. It's a half. And then you just use that half, that probability, and you multiply it with 300. And 150 times, you will get an even number. And the same, a 6, but there's only one 6 on the dice. So it's 1 out of 6 times 300, so it's 50 times. And that's how you use probability. And then, and as I said, I really want to run very fast through the basics. What is the probability of getting a 21? That is more or less the same. In geometry, if they ask you a geometry, just go and work out the area, and then take that area of the shaded over the total, and that's how you work with the geometry. But you can go through the blocks nicely, and then even the algebra. I want to more come to, and this is usually the one where the students start to struggle, and that will be the combined events. Okay, so can I just say, if there's 2 events, and usually, and I just want to use this, I don't see it now. If you see the word or, it usually means you must plus. Okay, let's go on. I'll show you now this example. So if they are going to say, I'm just going to make this bigger. Okay, if the 2 is nothing to do with each other. So if a club holds an election for the post of chairperson, the probability that the candidates Kisha and Nashala will be elected is 0,3 and 0,47. Find the probability that either Kisha or Nashala will be elected. They have nothing to do with each other, so I will just add it up. Do you see? the word neither. And don't forget that a certainty is 1. And then you will just subtract that 0.83. So, and I like using this example. Say the probability of red is 2/3. And I asked you, what is the probability of not red? Then it will be the certainty minus 2/3, which is 3/3 minus 2/3, and that will just be 1/3. So remember, not just take 1 and just subtract that. Okay, and then the next one, if some events are not separated, okay, there's a little bit of an overflowing, then all that you do, I'll just show, this is now a nice one with the cards. So a card is drawn at random from a pack of 52. What's the probability that the card is in red A? Now, these are the red cards. It's just sad that it's not in color, but this is the red card. And then how many A's do you just get 2? That's just the A. There. Yes, there is the A's. Pictures a little. But there's 2 out of 52. Now, if they say a black king, it's also 2 out of 52. And then they say a red ace or a black king, they have nothing to do with each other, so you just add it up. But what is the probability of a red card? Now, how many red cards is there? 26 out of 52. Okay, and it's sometimes the best not to simplify it and maybe just a final answer. And then I ask you, what is the probability of a king? Now, if I look at the kings, it looks to me, here is the kings. Okay, there's 1, 2, now let's just do it like that, because I think that's in black. So it's 1, 2, 3, 4. Can you see? There's 4 out of 52. But do you see that this 2 reds is also in this red block? So if I'm asking a red card or a king, and now you see there's an overflowing, you can still add it up, but that 2 that's in both, you're just basically going to subtract. And just remember that. Okay, the next one. Can I just show you this? The word and, that was or was plus, and the word and, can I show you? It's usually indicating multiplication. Okay, let's go to the next one. I'll show you now on the tree diagrams. Now, if there's 2 events, and I want to make a sketch here for you. There's not nice examples now in my exercise, so I think it's maybe good that I just go. If there's 2 events, now I just want to show you here. If there's 2 events, that 2 events can either be independent or it can be dependent. That's very important. So these 2 events can actually break up into this, independent and dependent. Now, if it's independent, it can break up that I do it on 2 ways. And this is one of the ways I make a possibility diagram. A possibility diagram. And this one, I make a tree diagram. But dependent, I just make a tree diagram. And please remember that. And I will show you to work on the trees and it work a little bit different. But this is just a possibility. So there's 2 dice. You write the one on top, the one at the bottom, and that will be all the possible outcomes. So all that white blocks will be 36. Okay, and then they just like asking you a few questions like this. And don't let it confuse you too much. You just have to, you have your possibility space. It's independent because it's 2 dice and the one roll on its own and the other one roll on its own, and they don't influence the other one. Okay, then they are independent. And then they just can say the sum of the 2 numbers is 7. Then you just have to go 7. What it can be 5 and 2. Do you agree? But it can also be 4 and 3, or it can be 3 and 4, or it can be 5 and 2. Do you see? Or it can be 6 and 1. and 1 and 6. So it's that whole row. Usually it works in this. And then I just highlight it or mark it, and that's 6 over 36, and I can simplify the final. Okay, that's possibility space. But I want to, and there's another one, you can go through that one. I want to go to the trees. Okay, because remember what I said. You have independent and dependent. Independent can be possibility space, but it can also be a tree. Okay, now this is just very, very important because working on the trees is the same. Completing the trees is different in dependent and independent. But if you look, just remember, okay, I'm just going to take these two events now. Okay, where am I? If there's two events, so this is the first toss, and this is the second toss. And if there's a third toss, it can be here. So for the first toss, and I think it was a coin, so a head is a half and a tail is a half. So for the second toss, it will also be half, 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 half. And this outcome, but this is very, very important. You can never just work with that number. You must always go back to the base. Did you see that? So if I ask you, what is the possibility of a head? You must go and you must say a half multiply in the tree, in the branch, I multiply. And if I say, what is the possibility of head tail or tail head? Now there's two outcomes. Okay, let's just see. I'll show you now. There's two. It can either be head, tail, or tail, head. Again, remember what I said. I still multiply there, and I still multiply. I cannot just work with this number, but the result, so I multiply in, but the result, I always add up. Are you with me? So after you multiply, you will just add the results. And this is what I'm trying to show you here. Can you see? So if you multiply, this is all your branches. This is going to be 1, 2, 3, 4. And very interesting, if you add all that 4 branches up, you must get a certainty. That's very, very important. You must get 1 because probability cannot be bigger than 1. And that whole tree must come to a result of 1. And this is why this is a property that I work a lot with. So if I say, what is the probability of not getting a head? Then you can just say 1 minus, and you just subtract that branch. And you say, I know I must multiply in the branches, but I want actually this one and this one and this one, but instead of working out all 3 and adding it up, that's another method. I just take my whole tree, which represents 1, and I just subtract that one, the not one. Okay, just keep it in mind. That's very important. Okay, and then 2 events, and I can just maybe, okay, this is now about, I think I want to do another one. I think I rather want to explain this one to you. That other one is easy. You can go through it. Okay. Now, you must always look at the 2 events and then determine, are they influencing each other? If they don't influence each other, then it's independent. Okay, so usually dependent will be, I have a bag of balls, I take 1 ball out and I do not replace it. So if there was 10 balls and I don't replace 1, there's only 9. Can you see the first action influenced the second one, and then they're dependent. But this is independent. Okay, you just read, and I think they're going to be nice and give you the tree. Otherwise, you just draw your own tree. So Kavari enjoys flying his kite. On any given day, the probability that there's a good wind is 3/4. So this first one is the wind. And it's either good or not good. The second one is about the kite. And either the kite flies or it don't fly. It flies, it don't fly. If you put fly on top, put fly on top here. And now just start filling it in. Okay. On a given day, the probability that there is a good wind is 3/4. Now, please remember, this one and this one must also add up to 1. So if this is 3/4, this will be 1/4 because it must add up to 1. Okay. Now, if there's a good wind, so go in your, find that row. If there's a good wind, are you with me? The probability that the kite will fly is going to be 5 over 8. And then I'm just going to write it in. This is 5, oh, this one, my pen is not nice. 5 over 8. And if this is 5 over 8, this must also add up to 1. Then this is going to be 3 over 8. Okay, then the last one. Okay. Then I'm going to take this. If there's not a good wind, find your road. If there's not a good wind, the probability that the kite will fly is 1 over 60. Okay, and then fill it in. So this is 1 over 60. This must add up to 1. So this will be 15 over 60. Okay, so the first thing, complete your tree. And then the second thing, they will start working with the tree. Now they will say copy and complete. What is the probability of a good wind and the kite fly? And now you must just find your road. Now I'm actually sad that I was marking all of them, because now I want you to find them. So I'm just going to clean a little bit my roads here. I want you to find it yourself. Okay. There I showed it to you. So, oh, this is nice. So I can work on this one. Because can you see it's exactly the same. Now, what is the probability of a good wind and the kite fly? First find your branch. It's a good wind and the kite fly. There's my branch. Now, can you still remember what I said? You take these two values and you just multiply. In branches, I multiply. Over branches, I will add. So I just multiply and use your ABC on your calculator. Let's go up. Then the next one. What is the probability of a good wind and the kite? Well, I did that one. Find the probability that whatever the wind, the kite does not fly. Now, where is the kite not flying? It's not flying there, and it's not flying there. But you cannot just work with that. You must always go to the origin. So you take a highlighter or a pen or anything you want, and I just see this is a nice color. Not fly. Not, oh, that is not the correct one. Not fly. So make sure it's not fly. Do you see that brown? Okay. And now don't forget, if you're going to write that, and please check here what I'm doing. I say 3/4, there's my 3/4, and I multiply it with 3 over 8. Did you see there? And then I say 1/4, and I multiply with 15 over 60. There I did. And then I just going to press it on my calculator, and I'm getting that value. And then the last one. Okay, find the probability where the wind the kite does not fly. If the kite flies, the probability that it sticks in a tree is a half. Now, if they bring in another inequality, it's nothing with the fly, nothing with the wind, they just bring in another one, then you're just going to multiply with it. But now, if the kite flies, the probability that it sticks is a half. Calculate the probability that whatever the wind, the kite sticks in a tree. Okay. Now, whatever the wind, the kite, okay, first find whatever the wind, the kite flies. So if the kite, this is very important. I'm missing this. If the kite flies, where is the kite flying? Can you see? So I can see that the kite is flying here. Do you see? And the kite is flying here. But I already have this brown. So I can say 3 over 4 multiply 5 over 8 plus 1/4 multiply 1 over 60. I can do that. But I can now just use my brown. I take my whole tree. What is my whole tree? That's 1. And I subtract. I know where the kite is flying. It's that 33 over 64. And then it will give me that red. And that will be 31 over 64. But if you are multiplying, adding, you will also get, and I'm going to make it in red, that you remember, you will also get that 31 over 64. Okay. And now they bring in, it sticks in a tree. Then you just basically take that extra fraction and you just say 31 and you just multiply with it. So if they bring in another condition. So it sticks in a tree. Just multiply with it, and then you get your final answer. Okay, this is independent trees. And please, I'm looking for my, I should have, okay. So I want to just show you here. This is independent. You can either do a possibility space or with tree. Now I'm with dependent, and that we usually just do with a tree. Okay, that's the last one. So let's just go. Still independent, and there's a lot, but some of them is quite challenging. I don't think that's more for AS level. Going a little bit higher. Okay, dependent. Yeah. Can I just show you? The only difference is to complete the tree. They're working on the tree. It's exactly the same. Now I want to start with this one. And how you know that it's dependent, this stands dependent, is they will say something like this. A bag contains 12 balls. 5 are red and the remainder are blue. 2 balls are drawn at random without replacement. That means there was, how many? 12 balls, but then they don't put one back. Then there's not 12 anymore. That's just 11. And that's why it's dependent. Okay, so this is my first draw, and this is my second draw. Now to complete the tree is a little bit different. So you have 5 red, 5 out of 12. So the rest is blue, 7. Remember, this must add to 1. But now, if they don't replace 1, then all these denominators will be 1 less. So if you have 12, I like it if you do it just like this. Just make 11, 11, 11, 11, and then just fill in your numerators. So basically, now if you complete it, you must use the word assume. Assume is just, you know what assume means? Maybe. I think in this one, I take the top one. I think it was a red ball. That means there will not be 5 red balls anymore. There will only be 4. But it was not the blue, so the blue is the same, 7. But you can test, this must still add to 11 over 11. Oh no, it was not the red. Cancel that assume. I think it was a blue. So for this one, you assume it was blue. So there was not 7 blue ones. Now there will only be 6. But the red ones will be the same. Okay, and that's how you complete. Working on the tree is exactly the same. So if I say both are red, find your branch. Why is my both are red? Red, red. So what do I do with these 2 fractions? 5 over 12, and I'm just multiplying with 4 over 11, and I get the answer. And then the next one, okay, and it's again a little bit the English, at least 1 is blue. What does that mean? Can be 1 that's blue, can be 2 that's blue. So there must just be a blue. Now if you look at this branch, I want to show you, and then I'll show you the other method also. Let's take blue. Okay, there's a blue. Do you see? This one is blue, and this one, at least 1. All that is blue. So you can say 5 over 12 multiply 7 over 11 plus 7 over 12 multiply 5 over 11 plus 7 over 12 multiply 6 over 11. You can do that. Or you can do the short way. The short way is I know that the tree will just add always to 1. If you add all 4 branches after you multiply, you will get 1. And then I just subtract the green. And I have not the green, it was the red. It should have been red. Let's just go for that red. Okay, then I just subtract that red. And what was that red? I was finding it there. 5 over 33, and that will give. So if I work with these 3 branches and I just add it at the end, I will also get 28 over 33. Okay. Oh, that is actually what I want to tell you here. I just want to show you, maybe if I go for a third one, I can go for a third draw also. So if I just, and then I just make another one. Okay. Gerard has 8 sweets in a bag. 4 sweets are orange flavor, 3 are lemon, and 1 strawberry. So now it's just 3 parts. Okay, but again, this must add to 1. So 4 plus 3, it's going to 7 plus 8, it's 8 over 8. And then it again divides in 3, 3. And if orange is on top, orange stay on top. And then, if there's a third sweet that they take out the first sweet, eat it, don't replace it. Take out the second sweet, eat it, don't replace it. So can you see, this denominator was 8. Then this denominators will all be 7. It's dependent. And then if I go for the next one, it will all be 6. And if I go for the next one, it will all be 5. Do you see? Every time one less. And then usually, okay, to find a problem if the sweets have different flavors, but there, if I must go for, and usually they will be nice. What they sometimes do is they take the top one. So if this was now, let me see, this was 3 over 7, then this one will be 2 over 6. Or they take the bottom one. So they're nice. There, it was also not so difficult. So this was 1, 0, and this will be 0. There was only 1 sweet. And then at 11, can you see, it was 3 over 8, then 2 over 7, then 1 over 6. Okay, so it's just become 1 less. And then working on the trees is the same. And I'm going to stop here. You can go a little bit more, but that's the basics of probability. And now, I just want to do that question. And I think in this video, I'm going to break it up again into 2. In this video, I'm just going to focus on probability. And then in the next video, I will then focus on statistics. Okay. Okay, and I think this is probability, this whole page. And I think the next whole page is statistics. It's working out nice. Okay, let's start with the first one. Tom has 50 model cars. Do you see that? He has 10 blue cars, 19 red, underline 10 blue, 19 red. He has no yellow cars. Okay. Tom choose a car at random. Okay. Write down the probability that it's red. Oh, and they will give you easy things also. So the probability of red. How many red cars? There's just 19. And what is the total? You always put the total at the bottom. 50. That's the answer. Then the second one. Red or blue, nothing to do with each other. So, and remember, or means plus, and means multiply. Okay, now what is red? What is blue? And that will give me 29, am I correct? And that will be over 50. Okay. And then not blue. Can you remember that I said that not? I have blue. I know what is blue. Just remember, blue, probability of blue